As you watch the next two segments on oceans and plant life, keep these questions in mind.
How have oceans promoted life on planet Earth?
How are plant and animal activities similar? The world's oceans are home to more than just fish. Thousands of aquatic species are swimming just below the surface of the water, and behind each species is the story of how it came to be.
What kind of life can be found in the ocean?
Shrimp, sharks, lobster, eels, I think big whales, barracudas, squid, schoolfish, crab, clams, oysters, shrimp. I said shrimp.
Earth is a planet of life with almost infinite diversity, but one tiny link unites every living thing: the cell. In many ways, human cells today resemble those of the first life forms in Earth's earliest oceans. 3.6 billion years ago, the planet's first unicellular organisms thrived in an environment that would destroy plants and animals today. Unicellular organisms, or organisms made up of one cell, are the simplest forms of life. Nitrogen, water vapor, carbon dioxide, and methane were the most abundant gases in Earth's atmosphere. Those gases exist in the atmosphere today, but nitrogen and oxygen are the most abundant. How could an organism breathe without oxygen? Scientists are unsure what the first life forms were, but they think they were unicellular organisms that did not need oxygen to survive. Though they don't know exactly what they looked like, scientists are confident that these organisms lived in the sea. It's likely that these simple single-celled organisms were unable to make their own food, so they used the surrounding chemicals for energy. Over time, these unicellular organisms started to evolve into multicellular organisms, or organisms made up of more than one cell. What are some ways that single-celled organisms changed? These organisms, known as cyanobacteria, combined water and carbon dioxide molecules within their cell walls to create a life-giving form of sugar called glucose. 6 billion years passed before photosynthesis, the chemical process of using sunlight to turn water and carbon dioxide into glucose, released enough oxygen to sustain life as we know it. As wind and rain wore down the Earth's surface, minerals from land flowed into the oceans, where new multicellular organisms waited to evolve. Oxygen-producing cyanobacteria changed Earth's oceans dramatically. The levels of hydrogen sulfide and other toxins decreased as the amount of oxygen in the water began to rise. With more oxygen, life in the oceans became more diverse. How can scientists know how diverse life in the early oceans was billions of years ago? Scientists rely on fossils to examine early life forms. Fossils are traces of organisms that have been preserved in rock or other substances. By studying fossils, scientists have learned about a five-eyed, ocean-dwelling organism called Opabinia, which has been extinct for over 500 million years. What other kinds of animals lived in the early oceans? Scientists have discovered a host of primitive animals by studying fossil remains. Nectocaris looks as if it has a head like a shrimp and a body like a fish. Dinomyscus resembles a flower, but it's really an animal. Odontogryphus, a multicellular organism from Earth's Middle Cambrian age, over 540 million years ago, has small tooth-like protrusions around its mouth. Its name means mystery with teeth. This fossil looked like the body of an animal. Just what kind of animal was harder to tell. Scientists thought that part of the fossil looked like jellyfish remains, while another part resembled fossils of early crustaceans. After more than a century of speculation, a plausible portrait of the fearsome creature developed. Growing up to 2 feet long and flanked by 14 pairs of overlapping flaps, Anomalocaris was the largest creature in the world during that time. In the billions of years since the first oceans formed, countless organisms have lived and died. They have helped change our world, and they provide fascinating details about our prehistoric planet. Did you know single-celled organisms, like bacteria, are among the oldest living organisms on the planet? The earliest records of their existence date from 3.5 billion years ago.
It's easy to look at a plant and not realize that it is a living organism. But if we speed things up a little bit, it's easy to see that plants can be just as lively and aggressive as some animals.
In what ways are plants active?
Plants go through photosynthesis where they create oxygen.
Plants like the Venus flytrap eat bugs.
That oxygen is used by all the other animals on the earth.
Coconuts drop on your head.
They help to break stuff down,
They decompose into the earth.
and they break down themselves.
Roots grow into concrete and break up the sidewalk.
Plants sway in the wind.
Pollen is blown around throughout the world.
Like all living organisms, plants must do many things to ensure their survival. Speed a week into a minute, and you can see the urgency with which plants race to unfurl their flowers. Wood anemones nod at the sun as it rises and sets each day. Hazel leaves pulse as they grow to their full size. This growth response toward or away from a stimulus is called a tropism. A plant's sensitivity to light, touch, and even gravity can affect where and how much it grows. Take this bramble, for example. This is a very aggressive plant. It waves its shoots from side to side as if feeling for the best way forward. And when a shoot settles on its course, it thrusts ahead forcefully. The invading stem's backward-pointing spines give it a grip to climb over almost anything that stands in its way. It can advance as much as 3 inches in a day. Before long, the shoot will put down rootlets and the bramble will have room for growth. Plants grow either toward or away from a stimulus, such as touch, light, or gravity. If a plant grows towards a stimulus, it is said to show a positive tropism. If a plant grows away from a stimulus, it is said to show a negative tropism. What are some other reasons that plants move? Plants also use movement to reproduce. Like animals, plants produce sperm and egg cells. Microscopic sperm cells are released from flowering male plants as pollen. Pollination, or the joining of the nuclear material in a plant's sperm cell and egg cell, can take place when a male plant transfers its pollen to the egg-producing part of a female plant. When pollination is successful, a plant embryo, or seed, develops. What happens to a seed once it is formed? Seeds must have access to water and space in order to grow. Shortly after they are formed, many of the successful seeds are scattered far from where they were produced. Wind carries flower seeds like those produced by dandelions. As dandelion petals fall off, the flower heads are transformed into wonderfully intricate globes over a period of 1 or 2 weeks. Each seed has an individual parachute. In a dense crowd of mature dandelions, there's little room for the next generation. The seeds need to grow someplace else, and the seeds having structures that enable the wind to carry them for miles will have the greatest chance for survival. Very little wind blows in the tropical rainforest, but many plant seeds can glide away on their own. Few seeds do this better than those of Borneo's liana. Aircraft designers have failed to build a wing as efficient as this one. Even the faintest updraft is enough to lift this little glider with its seed passenger. What are some other ways that seed dispersal takes place? Plants sometimes explode to spread their seeds to less crowded areas. This is a Himalayan balsam. Its seed capsules are pumped so full of liquid that the slightest touch makes them burst. with a force so great that seeds may shoot as far away as 15 feet. Some plant seeds disperse through the air, but most travel on other living creatures. The burdock has hooks, hundreds of them, that latch onto hairy animals. Plant seeds that hitch a ride with animals can cover a lot of ground in a short time. So when an animal licks, picks, or shakes off one of the burrs, there's a better chance that the seed will survive because it often lands in a spot where light, water, and space are readily available. In addition to helping distribute pollen from male to plant structures, insects are also reliable agents for seed dispersion. What are some ways that animals disperse plant seeds? Ants are adapted to eat the outside of plant seeds while leaving the fertilized egg intact. Ants carry the seeds underground and eat the fleshy bit at the end. When they are done, the seeds are left to germinate just below the forest floor. It can take months or years for a seed to grow into an adult, but once it does, it will be able to reproduce and start the plant's growth cycle all over again.
You've been given all the information. Now it's your turn to discuss the questions. Take a moment to talk about the following.
How have oceans promoted life on planet Earth?
How are plant and animal activities similar?
If you'd like to learn more about what you've just seen, go online or check out these books at your local library.
As you watch the next 2 segments on adaptation, keep these questions in mind.
How are adaptations important for survival?
What environmental challenges cause animals to develop adaptations? Most insects are small enough to fit into the palm of your hand, but size, like other differences, are only adaptations that have helped insects survive for millions of years.
Have you ever seen a really strange-looking insect?
One time I was taking a shower and there was like a long, I don't know what kind of insect, it was like a water bug.
And spit, like my cousin, with like their little clampy mouths.
Once when I was 7 or 8, I was looking under a rock in my backyard and I picked up this brightly colored beetle. And I was walking and suddenly it jabbed something into my hand and I was bleeding and I was really terrified after that.
I do remember a long time ago that there were a lot of cicadas around, and I just didn't like them at all. They were making so much noise.
I used to have nightmares about Daddy Longlegs climbing the walls in my room.
There was a really disgusting insect on my wall.
Planet Earth, 300 million years ago. A world of lush green forests, sanctuary for creatures gaining a foothold on land, and the home of thousands of insects. Even then, insects of myriad designs were evolving. What are some ways that all insects are alike? Insects are arthropods with 3 body sections, 6 legs, 1 pair of antennae, and usually 1 or 2 pairs of wings. They are also invertebrates that have exoskeletons on the outside of their bodies. Today, most insects are small enough to fit in the palm of your hand, but millions of years ago, these tiny creatures could grow to be much larger. Why would giant insects over many generations become smaller to survive? If a beetle measuring half an inch long could grow as large as some vertebrates, its anatomical design would spell disaster. Its protective shell would be stretched so thin that its inner body would collapse. If its exoskeleton were thick enough to support a giant body, the beetle would fare no better. To hold the beetle's weight, the shell would have to be so thick no space would be left for muscles and organs. Exoskeletons were an evolutionary innovation, but they had their limitations. Size was only one adaptation. What are some other ways that insects have adapted to their surroundings? Insects usually have 2 large compound eyes, which contain many lenses. Viewed in cross-section, the compound eye appears very thin, like a layer of film. 2,000 of these lenses together occupy only 1 tiny square millimeter of space. Compound eyes are especially keen at seeing movement. Small and adaptable to a variety of habitats and food sources, insects are masters of survival. One of the insect world's most effective survival tools is sound. All sound is a series of vibrations that create outward moving waves. How do insects make sounds? Many insects make sounds by rubbing a roughened part of their body against a sharp-edged part. The sound produced by the rubbing is a signal to other bees that food is near. But insects don't use sound just to find food. Many insects use sound to attract mates. What other adaptations have helped insects survive? Simple adaptations have made insects a diverse and resilient group. One adaptation, the elaborate technique of camouflage, is a great natural defense. Insects use protective coloration to blend in with their surroundings. Camouflage often makes an insect nearly invisible to a predator. The praying mantis is cleverly hidden. It is camouflaged green to blend in with the leaves. Another insect called the walking stick is brown. To protect against winged predators like nightingales, whose diets include insects, the walking stick's color matches that of the branches in their forest habitat. Today, insects account for at least 70% of the animal species on Earth. They have adapted so successfully that they have outlasted the dinosaurs and a host of other creatures, both great and small. Did you know? Unlike humans, bees have adapted to see ultraviolet light. Scientists at NASA's Jet Propulsion Laboratory have created a microchip that can pick up ultraviolet signals. Researchers hope that this bee vision might be used to help explore distant planets.
Dogs have been living with humans for thousands of years, but they weren't always the likable, lovable companions we know today. And every once in a while, you can still see their wild side.
What kind of dog do you like?
Golden Retriever, the miniature long-haired dachshund.
Beagle.
A Lhasa Apso.
I have a dog. His name is Tyson. He's a Yorkie.
My dog is a huntress, which makes her actually similar to wolves.
He's the cutest dog.
I have a small white Bichon Frise.
It's little, but at the same time it's cute.
He gets a really girly haircut.
He's a little hard to train and extremely spoiled.
Fluffy ears, a little bob.
They're almost like a person. And she has
black nose, and he has a pink star-shaped birthmark on it.
He's very docile. He would never hurt a fly. He's afraid of cats, in fact.
At times, dogs appear to move and react like wild animals. Yet by definition, they are domesticated. In the past 14,000 years, humans have manipulated a single animal species to create more than 400 breeds. But despite their variety of appearance, all dogs are really mutations of their closest ancestral relative. The wolf. Wolves and humans competed against one another for game. Both developed ways of communicating that would allow them to hunt in groups. Perhaps the wolves were drawn in by the smell of meat cooking over a fire, and into contact with their human rivals. Eventually, some wolves may have stayed to scrounge scraps. The humans allowed these less aggressive and more curious animals to remain nearby and breed. It's possible that in the wild, the other wolves would have made this meeker behavior harder or even impossible.
This is the starting point for obtaining the DNA to do the genetics research.
Evolutionary geneticist Dr. Rodney Honeycutt is trying to figure out precisely how domestication occurred. His analysis may even reveal where wolves were first domesticated and when.
Domestication is a very rare event, really. It's not something that humans in their great wisdom can do multiple times. It obviously was something that occurred not many times, and it might have been blind, stupid luck that allowed us to domesticate a particular species to begin with.
But how quickly could wolves have been domesticated? It was once thought to have taken hundreds or even thousands of years. In Siberia, an experiment gone wrong has changed that view. More than 30 years ago, the Russian fur industry tried to breed tame silver foxes that were easy to handle in order to make their fur easily available. It took less than 25 years to achieve adult tameness that could be reliably reproduced from one generation to the next. But in domesticating the silver fox, the fur industry got more than they bargained for. The foxes inherited the juvenile's tameness and continued to behave like puppies well into adulthood. White markings began showing up on the foxes' heads and chests. Some developed floppy ears, and their tail lengths became unpredictable. In the wild, such mutant animals may not have found mates, and the characteristics would not have survived.
Посмотрите, это очень интересное животное. В результате доместикации это животное имеет наполовину один глаз голубой, белые бока и очень интересный хвост. Форма хвоста интересная.
These changes in physical appearance made the foxes useless to the fur industry, but it did illustrate how quickly the wolf could have been tamed and physically changed. Can you think of some ways that taking an animal out of the wild would change it? Although it's easy to see the wild wolf beneath the skin, domestic dogs have been bred into very different creatures. But with 400 different breeds, what are some of the dog's basic characteristics? Many dogs in the third world appear to share the same physical features.
Well, in my mind, the third world dog, and Lizzie here is a classic example, about 35 pounds of perfectly proportioned canine intelligence. The third world dog is a natural dog. She's not been subjected to selective breeding by human beings. She's not been shaped to conform to some particular human ideal of perfection or utility. She's been shaped by the forces of nature.
These fine-boned and thin-coated dogs of the South American rainforest look like dogs throughout the tropics. On the remote Mongolian steppe, another natural dog shares life with nomadic people. These northern dogs are larger, bigger boned, and have thicker coats for a colder climate. They must be sturdy enough, even as puppies, to travel long distances. Nomadic people may move every few weeks to find better grazing for their livestock. The dogs are expected to keep up, or they will be left behind. These people value their dogs highly, feeding them the same rich goat's milk that they drink. Some Mongolian dogs have been selectively bred. One such breed has tan markings over the eyes that gave rise to their name.
The Mongolian four-eyed dog is a wonderful example of how we can creatively reassemble canine genes to have an incredible effect. Because the direct stare on a wolf of two eyes is threatening, but to turn it into four eyes is even more intimidating.
In the West, dogs are still used in traditional ways to solve a familiar problem. In the Colorado Hills, Maremmas, a herding breed of dogs from Italy, guard a flock of cashmere goats against a coyote, a dog relative. Raised among goats, the Maremmas identify with the flock and protect the goats from predators. The dog's special relationship with their flock is the result of imprinting. Imprinting refers to a newborn animal's desire to follow the first object it sees. A newborn animal has an instinct to follow a moving object, but it's not born knowing what its mother looks like. Experience teaches it what or who to follow. As the dog grows, it learns to treat the imprinted object as a member of its family. The Maremma considers itself a part of the flock. Because the Maremmas keep the goats safe, farmers can leave the coyotes alone. The coyotes will need to find other sources of food. In the winter, coyotes scavenge wherever they can, even stealing fish from the mouths of otters. Coyotes are symbols of the American wilderness, and yet have had to adapt their scavenging skills to man-made environments. Today, thousands of coyotes live within the greater Los Angeles area. The wolves have not been so adaptable. Wolves were once the most widely distributed land species after humans, but some have been driven to the edge of extinction because humans feared them. Still, these predators survived, thanks in part to their ability to operate in packs. They live and hunt in well-organized teams, each member aware of its place. Members of the pack protect each other and work together to find food. Ritualized play fighting reinforces the hierarchy. Domestic dogs don't appear to have a social structure like that of wolves. And yet dogs and wolves are probably a single species.
They are so ugly. And I can say that because I've tried.
Compare their genes, and the elegant Borzoi of Russia and the minute Mexican Chihuahua are virtually identical. The Chow Chow of China is indistinguishable from Australia's Silky Terrier, and indistinguishable too from the wolf. The New Guinea singing dog is one of only a few breeds that differ genetically from the others, and they are behaviorally unique as well. True to their name, they do not bark, they sing.
I think that the reason you see some of these particular dog breeds being very divergent has to do more with isolation than anything else. And so you don't have any pollution of the gene pool in these populations, so they maintain their uniqueness relative to, say, some other breeds.
But even with these differences, Rodney Honeycutt now believes that calling the domestic dog a separate species, Canis familiaris, should be called into question.
Canis familiaris probably doesn't exist as a species. As far as I'm concerned, based upon our genetic analysis and from a phylogenetic standpoint, it's probably no more than a race within Canis lupus, the wolf. And there's no good evidence based upon really any definition of a species to suggest that the domestic dog really deserves species status.
So where did the domestic dog come from? Its oldest ancestor was a tree dweller, known as Hesperocyon, or dawn dog. Short-legged and long-bodied, it differed only slightly from the ancestors of the cat. Dawn dog's descendants evolved into the canid family we know today. Dogs are carnivores, or meat-eaters. But over time, they've developed the ability to eat and digest vegetables as well as meat. They are able to do this because of a modification of their teeth. A characteristic of carnivores is molars with a sharp cutting edge. The dog's molars have a grinding surface behind the cutting edge that allows fruits and vegetables to be chewed well. This sort of dietary adaptability opened the way for the canids to colonize the world, from the frozen Arctic to the furnace of the Sahara. A golf course in urban Colorado is home to a thriving population of red foxes. Unlike wolves, foxes do not live and hunt in packs, but they can have surprisingly complex family lives. Here, squirrels are favorite prey. This male has made a kill and keeps rival foxes at bay. Even his own mate. But out of view of other foxes, he passes her the carcass. She takes the prey home to their 4 growing kits. At the den, the dead squirrel is snatched by the most dominant, or alpha kid. Without intervention, the alpha would prevent his siblings from feeding. He even resists his mother's attempts to claim back the carcass. After a while, she finally succeeds in taking the squirrel from the alpha kid and gives it to a waiting sibling. Vocal communication is common on pack-forming canids. In India, a wild dog known as the dhole communicates using a repertoire of shrill whistles. These dogs live in dense vegetation, and whistling enables them to hunt cooperatively, even when they can't see each other. On the plains of southern Africa, the most endangered of all canid species also hunts cooperatively. The African hunting dogs work as a pack to bring down large, powerful prey, like a wildebeest. This one kill could feed the whole pack. The pups wait back at the den. Often, the dogs hunt a long way from the den, so the adults carry the food back in their stomachs. It's an effective means of transportation. When they return, they feed their young. The entire group, from the alphas to the most subordinate members of the pack, work together to care for the pups. From the time they are a few weeks old, a domestic puppy's development, which should be directed by the pack, is taken over by a human. How does the puppy react to the human? A very young puppy instinctively follows the first moving object it sees. This object is usually its mother, but humans and other animals can imprint themselves on young animals. These animals will react to humans as if they were parents. In addition to raising dogs, humans have bred them for specific physical characteristics. Most dog breeds have come about in the past 100 years or so.
To me, the most intriguing thing about all this is the fact that you can take wild canids, and if you look at a wild species of wolf, coyote, or jackal, they look very similar. But under the surface, there's this incredible wealth of genetic variation that allows for this animal to be manipulated through breeding to uncover this incredible diversity that we call the domestic dog.
Humans have taken that underlying diversity and created giants like the Great Dane and dwarfs like the Chihuahua.
Okay, come on, sugar.
And while some varieties appear to be the result of a bizarre aesthetic, others reflect a practical origin. What are some of the things that dogs have been bred for in the past? This grooming may look frivolous, but it may have been conceived in the Middle Ages. The idea was to help make the standard poodle fast and buoyant while swimming, and to keep the dog's vital organs warm when they retrieved ducks from cold waters. Tenacious cairns once hunted English foxes and rats. Basset hounds' long ears help them pick up the scent of wild game from the ground and move it to their noses. A few breeds have been around for hundreds of years. Irish wolfhounds, Ibizan hounds, and Afghans were bred to chase wolves, rabbits, and other prey. With our ability to manipulate the dog's physical appearance came our success at exploiting some of their most acute sensory skills. This beagle uses his finely tuned senses of smell and hearing to prevent structural damage to houses.
Seek him out. Let's go. Let's go. Let's go. Good dog. Let's go. Good boy. Let's go.
These canine pest controllers can locate concealed termites from as far away as 16 feet.
Good boy. Seek him out. Show me. Seek him out. You go seek. You go show me. Good dog.
Unaided human inspectors find infestations about 20% of the time. Dogs are close to 100% successful.
Seek him out. You go show me. Show me. Seek him out. You go seek.
A powerful sense of smell and a hunter's instinct are effective weapons in the war against drugs.
Look your butt! Look your butt!
We're teaching this dog a new odor. We're doing some field exercises, what we call a control retrieve. I've got a scented towel. I'll throw it. The dog, it'll be on sight the first few exercises. Once he's carried around and adjusted, he said, I know that odor, then we can start to hide it in some areas where he has to look for it. But right now, it's just a sight.
What's on the towel?
This is pseudo-cocaine. That's what we're using right there in this little cloth bag. The dog can't get to it. We've never had one yet. You would think they could get to it, but we've never had one break into that yet. And it's like I said, it's only pseudo. We couldn't tie the real stuff on. You ready, Chris? Are you ready, buddy? What is that? What an intense look on that dog. Atta boy, get after that. There you go. Is this? Hey Tony, is this the same Chris? No, it's different. He's Chris in a wolf's coat.
Drug enforcement officers often adopt dogs from pounds and shelters.
Get him up there, good prep and move. That's it. Let him have that leash. Let him have that leash. Watch your leash, it's tangled around his neck.
Like humans and other animals, dogs must be taught how to identify drugs before they are able to work with the police. That way, their behaviors result from experience instead of instinct.
How many dogs make it? Only 1 out of 45 dogs that enter into the training course graduate. That's a very low percentage. Very, very, very low. The reason for that is a very hard job. In order for the dog to detect this cocaine or heroin, the dog must be within 6 inches searching the vehicle, searching the suitcase, or searching the box. Get him up on there. Little more leash.
Every dog must pass a difficult test in order to graduate from the program. They must learn to walk on a moving conveyor belt while searching for drugs.
Try to just tap those seams if his head comes up a little bit. Let's let him tear it up. Let him shred it. Pull that box. Come on. Gotta hold it down. Gotta hold the box down when you pull it.
A dog that might tear up the family couch and dig crater-sized holes in the backyard makes an ideal pupil for drug dog training school.
Good girl. Good girl. See?
In the remains of a burned-out house, Villain and her partner Bill search for signs of arson.
Show me.
Villain can detect minute traces of flammable liquid, down to 1/500,000th of a drop. Without this help, chemists would have to analyze all of the remains instead of just those areas pinpointed by the dogs. What are some other ways that dogs are trained to help humans? At the Oklahoma City bomb site, the dogs work to locate victims buried in the debris.
An air scenting dog like Duchess is capable of going out and smelling what we believe are dead cells that are coming off the skin of the body for both live and dead people. So days, weeks, even sometimes years after a person has gone missing, these dogs are very valuable resources in identifying exactly where an individual was last seen. What you got there? Oh, good girl. Duchess, come here. Come here. Canine 21 to Fairfax.
Fairfax Command, go ahead.
Be advised, we found a jacket, a black jacket that meets the description of the profile on the subject.
Fairfax, copy that information.
A dog's sense of smell is incredibly strong. But can a dog be taught to pick out the smell of disease from all the other hospital odors, like tape, gauze, disinfectant, and gloves?
Good girl. Good.
And can it even distinguish between cancers and other diseases? At Tallahassee Memorial Hospital, Breeze and George are learning to sniff out malignant melanoma or skin cancer.
And work around this way and come completely around and then look around. Okay? Okay.
The dogs have proven in tests like this that they can detect malignant melanoma with near total accuracy. But how do they do this? In both dogs and humans, the olfactory bulb gives us our sense of smell. Dogs have an olfactory bulb in their brain that is 4 times larger than that found in humans. And even though the human brain is 10 times larger than a dog's, the canine sense of smell is at least 100 times more powerful. At the moment, Breeze and George are probably unique, but there's no reason other dogs can't be trained in similar skills. What other skills make dogs unique? Because their ancestors evolved to hunt at twilight, a dog's eyesight is sensitive to low light conditions. Unfamiliar aromas bombard their nasal passages. And with their sensitivity to high and low frequency sounds, the noise ricocheting off the walls is magnified. Successful training is learning to shut out all these distractions. Domestication comes with a price. Although DNA tests have shown that wild dogs, like the New Guinea singing dog, are generally free of hereditary diseases, a number of domestic purebreds are not.
Yeah, I picked 6 off of each of these 2 filters, different ISOs.
A team of molecular biologists in Ann Arbor, Michigan, are detecting and profiling canine genetic disorders. Using the tools of biotechnology, they map canine genes in an attempt to locate and identify the sites of at least 350 genetic disorders that afflict many purebred dogs.
Purebreds were originally derived from a few founders, and as a result of that, the occasional recessive genes, harmful genes, disease genes that these dogs carry, have been amplified and perpetuated in a particular breed. So what we see in a breed, a particular pure breed, is a focusing and an amplification of particular diseases. It's not unlikely that that upwards of 20% or so of dogs have a significant genetic disease. I believe that the development of some of the purebreds has been a disservice because it's resulted in physical conformations that are really pretty unhealthy.
So unhealthy that the Chinese crested can tolerate little direct sunlight. bulldogs have such huge heads that most pups are delivered by cesarean section. Their breathing is compromised by short muzzles with teeth jammed into a small mouth. And Shar-Peis, dogs of China bred in the United States from just 8 individuals, are prone to agonizing skin disorders. Pet stores sell puppies of almost every size and shape.
Yeah. She knew what she was saying.
Most of the animals come from puppy mills, where hundreds of female dogs produce as many pups as possible. The problem is that people who sell puppies for mass consumption know little about the animal's genetic diseases, and the people who buy puppies often do so on impulse. Humane societies estimate that between 4 and 8 million dogs in the U.S. end up in pounds and shelters each year. Though most puppies are adopted, 60 to 70% of the older dogs will be killed. An animal domesticated by humans can also easily be discarded by them. Long before humans domesticated anything, thousands of years before we tended flocks of sheep or herds of cattle, before we harnessed the power of the horse, and before we thought about cultivating plants, we roamed vast wildernesses with our dogs, trained them, and depended on them. Yet they remain wild to some degree, because just below the surface, they are what they have always been.
You've been given all the information. Now it's your turn to discuss the questions. Take a moment to talk about the following.
How are adaptations important for survival?
What environmental challenges cause animals to develop adaptations?
We hope you've enjoyed this assignment discovery journey into the living world. If you'd like to learn more about what you've just seen, go online or check out these books at your local library.